Good evening to all. Is the video clear? And audio too? Thank you. Any queries regarding the daily test which is posted to you? Say. Right? Then I think yesterday we have a small disturbance with regard to net connectivity. I think there I am discussing about inspection method. Am I correct? Yeah. Is the visual clear till the end of this discussion, or we dropped in the middle? Can you say? I have written a list of formulas there where we are going to use them in solving the problems. Yeah. Then I repeat that again. The main objectivity of integrating factor is nothing but to make the differential equation exact, nothing but it is integrable. So on doing the integration, you are going to get the relation between x and y. Method of inspection says that on observing the terms in the differential equation, by simply rearranging the terms or multiplying, adding, subtracting, dividing the terms of the equation with suitable function, we are going to represent the given equation as an integrable equation. Let me say, suppose we have y dx plus x dy equal to 0. This is an equation. So we can write this equation as derivative of xy equal to 0, so that it is easily integrable. Accepted? Yes or no? So in the same manner, whatever the given equation is there, by rearranging the terms of the equation and doing suitable adjustment in the equation, we are going to make it as integrable. That is the main logic here, which is nothing but inspection method. So it requires a little practice, and now I am going to give the list of derivatives to you which are known to you. So whenever those terms occur in an equation, we are going to make use of them. Fine. So please take a note of that. So just hold on a second, I am going to write them. Derivative of x square plus y square by 2 is equals to x dx plus y dy. Derivative of x by y is equals to y dx minus x dy by y square. Similarly, derivative of y by x is equal to x dy minus y dx by x square. Derivative of y square by x is equals to 2xy dy minus y square dx by x square. Derivative of 1 by xy equals to x dy plus y dx by x square y square. Derivative of log of x by y equals to so please take a note of them. So you just understand one thing, that I have written some of the functions corresponding their derivatives. These are not fixed. You can have so many functions and their derivatives are known to you. Whenever the given equation contains these terms, we are going to make use of them, the corresponding formula, right? Is the logic clear to everyone? So after noting, please inform. I just want to take one or two examples on this randomly so that you can have an idea what is the importance of this inspection method. Shall I continue then? Yeah. If I have written anything wrong, please correct me. Writing those differentials. Thank you. So solve the equation x dy minus y dx equals to xy square dx. Please take a note of that. Now tell me, on doing what kind of arrangement in this equation so that we are going to write it as derivative of some function will exist in the given equation. Can I say that if I divide the equation with y square, then what happens? Is it acceptable there? Say, can you write that as a derivative of some function? Yeah. It is also agreeable, right? Now here, x and corresponding differential is existed here. So you can integrate this, and this is derivative of x by y. So you can directly integrate the given equation. Hence, the result will come as accepted or not. Okay. Any modifications? Yes or no? All of you agree with this solution? Thank you. So let us go with one more small thing. Then you have an idea what is to be done here. Y minus xy square into dx plus, minus of x plus x square y into dy equal to 0. So please take a note of this. So whenever this kind of thing is given, first we simply split all the terms, then we are going to arrange them in an order. So we can write it as y dx minus xy square dx minus x dy minus x square y dy equal to 0. And for convenience, y dx minus x dy minus of xy square dx plus x square y dy equal to 0. Tell me what is the modification we are going to do here. So take your time and think of that. So divide with x square, so that the whole thing will become derivative of something. Okay, divide with xy. Let us check what happens. If you divide with xy, then it will be 1 by x dx minus 1 by y dy minus of xy accepted. If you divide with xy and you are going to make it integrable, variable corresponding differential existed side by side. So if you integrate, its value is log x minus log y minus xy equal to c. You can go for different modification in the final answer, the simplification part. On the whole, this is one kind of procedure we are using under inspection method, right? So is the approach clear to everyone? What we are doing in the inspection method? So here we have to understand one simple thing, that whenever the given equation is non-exact, generally we go with the procedure of integrating factors. So far we have discussed it. At the end, if the equation is easily solvable on arranging the terms, then you can go with inspection method. Otherwise, we always stick on to the integrating factors only, the standard procedure described earlier. Fine. So if it is clear, then I go with linear differential equations part. Shall I? So please take a note of this. So in the examination point of view, it has less priority, the inspection method has. More priority is given to integrating factors only. So after noting, please inform. And I think that majority of you have the idea with regard to linear differential equations. Can you recollect that? What is a linear differential equation? Fine. So in this ODE topic, I am mainly sticking myself to discuss about the procedures in solving different kinds of equations, because knowing theory is not our criteria. We are going to solve more number of problems based on the previous year questions approach. So I am going to describe the procedures one after the other. There we are going to solve numerous problems. So take linear differential equation as the another topic. So we know that the equation of the form dy by dx plus p into y equal to q is called a linear differential equation. So in other way, you can say that dy by dx plus some coefficient into y equal to some terms. So here is a function of x or a constant. Here also you have a function of x or a constant. So whenever an equation is given in this form, we are calling it as a linear differential equation. And you can observe that it is the first order and also first degree differential equation. So by simply doing the cross multiplication, you can arrange this equation in the form m dx plus n dy equal to 0, and it is a non-exact differential equation. So if you want to solve the equation, we are going to find the integrating factor. So here the integrating factor is given by e power integral p dx for the given equation. So in solving the procedure, see, let me say one thing. We are going to represent in this manner. Accepted? Say, right. So can you say that it is of the form m dx plus n dy equal to 0? Right. So if you consider the partial derivatives, it is non-exact. Dou m by dou y not equal to dou n by dou x. So in general, if you go on to do the integrating factors method, integrating factor is nothing but e power integral p dx for this equation. Whenever an equation is given in this form, say only dy by dx plus some value into y equal to some value. Here it is containing only x terms or a number. Here also it is containing only x terms or a number. Such type of equation form, we are calling it as linear differential equation. Since it is a non-exact equation, integrating factor should be found. So what is the formula for integrating factor? It is e power integral p dx. And the solution of this equation is given by y into integrating factor equals to integral of q into integrating factor dx plus c. So this is the formula for finding the general solution whenever you have linear differential equation. In general, linear differential equation can be classified into two types. One is of the form dy by dx plus something, where y is dependent, x is independent. And the other is given by, take the opposite differential, dx by dy plus some value into x is equal to some value. You can take it as p1 q1 for convenience. So whenever the given equation is taken in this form, what will be the integrating factor? It is nothing but e power integral p1 dy. And what will be the general solution? X into integrating factor equals to integral of q1 integrating factor dy plus c. It is just the opposite to this case. So please note down the two formulae. When the equation is given in this model, this is integrating factor and this is general solution. If the equation is given in this type, this is the integrating factor. Here you replace x with y. That will be the corresponding solution. Okay? So after noting, please inform. Any queries in getting the idea of this formula? The procedure approach. Sir, no? Right. So let us take one or two problems on this concept so you can have an idea. I think you have done so many problems on this type. Am I correct? So may I know how many of you have the prior idea with regard to this type of equation and you have solved them earlier coming to these class sessions? 2, 3, fine. So let us take one or two sample problems on this. Take one thing. So 1 plus x square into dy by dx plus 2xy minus 4x square equals to 0. Here, please understand one thing, that by converting the given equation into linear form, it is very easy for us to solve the equation. Apart from this, by simply multiplying the equation with dx, you are going to get the form of mdx plus ndy equal to 0, and there you are going to solve with your previous approach. That is also acceptable. Why we are using linear differential equation? Because it is easy to solve. That is the only criteria here. Okay. So dividing the given equation with 1 plus x square, you have dy by dx plus 2x by 1 plus x square into y is equal to 4x square by 1 plus x square. So please understand one thing, that the given equation is converted in the form of dy by dx plus p into y is equal to q. So after converting into this form, you are going to do the respective procedure. So p equals to 2x by 1 plus x square and q equal to 4x square by 1 plus x square. Now let us do the integrating factor. So e power integral p dx. So e power integral 2x by 1 plus x square dx. Since the derivative appears in the numerator, is e power log of 1 plus x square equal to 1 plus x square. Accepted? Any queries? Right. So the general solution is given by y into integrating factor equals to integral q into integrating factor dx plus c. So y into 1 plus x square equals to integral 4x square by 1 plus x square into 1 plus x square dx plus c. So there you have integration of x square is x cube by 3. So on the right hand side you will have 4 into x cube by 3 plus c will come. So that is the general solution of it. So please take a note of that. So if this approach is clear, let me take one more problem on this type so that you can have the complexity what will be asked on this model. And the usual weightage of these questions will be minimum 10 marks. You cannot expect 15 marks on this. The only thing is, whenever higher order differential equations are there only we can get 15 marks questions. However, whatever the general question is given on ODE, generally the minimum weightage is only 10 marks because every student is well versed with differentiation and integration. The only thing is applying the suitable formula at that mode. That's all. Any source for formulae? Can you elaborate that one? just to rewind, what are the formulae are there on total ODE you are asking? Yeah, I will give at the end. Once finishing with all the things, I will give the gist so that you can have a good idea after completion of ODE. Topic wise formula I will list out. So this is the problem. Cos square x into dy by dx plus y equal to tan x. So I will post the same request to our admin sir so that it will be posted on the platform. So can you need more elaboration on this model, or this type of explanation is sufficient for you? Okay. Is it comfortable for you in getting the idea how to solve it? Thank you. So in order to convert that in the standard form described earlier, so divide the total equation with cos square x, then dy by dx plus secant square x into y equal to tan x into secant square x. Or you can simplify on the right hand side also, no problem at all. Now what happens if you compare the given equation with the form p is equal to secant square x and q is equal to tan x into secant square x. So integrating factor e power integral p dx equals to e power integral secant square x dx equals to e power tan x. Fine. Now let us apply the general solution here. So y into e power tan x equals to integral q means tan x into secant square x into e power tan x dx plus c. Now to evaluate the integral, let us take that tan x equal to t. So secant square x dx equal to dt. Substituting these values in the integral, it will become t e power t dt plus c. And you know the formula for this one, it is t e power t minus e power t plus c equals to so that is the general solution. So you can common tan x also. So e power tan x minus 1 into tan x plus c. That also you can write. Now, can I say one thing here? If you convert the given equation in the form mdx plus ndy equal to 0, there I have given earlier 5 formulae like mx plus ny, mx minus ny, etc., etc. Are those formula are useful here to evaluate the integrating factor? Say. So you can check on that. So straight away this is the formula. Even though if you are able to find the integrating factor, it takes a little time to evaluate the equation. So please understand one thing, that the method is described to solve an equation in a simplified manner. So in order to solve a differential equation, multiple methods are available. So on the whole, we are just using a method which is convenient and solve. That's all. as we know that integrating factor is not unique, there will be more number of integrating factors. So since we have done with the first model of the linear differential equation, let us take one more on the second model, dx by dy type, so that we can conclude this thing. I will move to the next topic. Shall I? The most complex question, let me say, the question which is going to be taken by me is asked in the previous year questions that you can expect. See, the complexity you cannot expect. Please understand, ODE is very easy. It is just nothing but knowing the formula for that question, isn't it? If the formula is not known to you, are you able to solve the question? Say, that's it. That is the only thing. Except that nothing is there in ODE. Because if every topic is difficult in the math syllabus optional, no one will take maths optional as their favorite subject. So please take a note of this. And personally, as a teacher, I feel that an examination will be conducted to test the student and gain his knowledge and not to fail the student. That is my personal opinion. So if I am the paper setter, I won't give such type of complex questions. On the whole, I will give the list of questions which take more time to solve in the stipulated period. That's all. So please note down this question. So let us do like this. 1 plus y square into dx by dy equals to tan inverse y minus x. Again, dividing this thing with 1 plus y square and taking x to this side. So this kind of complexity you can expect on LDE, I can say, because the weightage is just 10 marks. So whenever this question is given, people usually get confused that what type of conversion we need to do here. Is it dy by dx or dx by dy? So one general observation is that if x has power 1, it will be dx by dy. If y has power 1, then it will be dy by dx. If the equation is straight away looking as dy by dx, it is okay. If you are able to convert in the form, this is one type of observation you can take. Yes. So y or x should appear individually with power 1. That is also acceptable. Basically, it is nothing but mdx plus ndy. Nothing wrong is there. You can apply the previous methods. Straight away you can solve that. Now, the tricky thing is, if you go with mdx plus ndy, you are going to waste your time by calculating the so many integrating factors, isn't it? Yeah. So, unless you know on what type you are going to convert, either dy by dx or dx by dy, it takes 5 to 10 minutes wastage of time in the examination point of view. There you miss the whole thing, isn't it? It is just to confuse you and waste your time, that's all. Otherwise, there is nothing specialty in the question asked. Right. So it is of the form dx by dy plus some value into x is equal to some value. So we need to solve in given time comparison between two. So you are saying that which one is easier, mdx plus ndy or dy by dx. Obviously, dy by dx method is convenient and easy to solve. And you should be able to decide which type you are using, dy by dx or dx by dy type. So getting this type is most important apart from solving. Once you know the type, you are able to solve it very easily. This conversion is important there. Fine. So if you go for integrating factor, e power integral 1 by 1 plus y square dy. So e power tan inverse y. As per the general solution formula is given, x into integrating factor is equal to integral q means tan inverse y by 1 plus y square into e power tan inverse y dy plus c. So to evaluate the integral, you take tan inverse y equal to t. So 1 by 1 plus y square dy is equal to dt. So substituting these values here, it will come under the form t e power t dt plus c. So equals to e power t into t minus 1 plus c, and you substitute what is t there. That's all. Just I ask one question to you. On straight away seeing this, are you able to get the thought that it is of the type dx by dy? Please tell me. That is the thing. At least you have to think 1 or 2 minutes so that it is linear model. We are going to use the prototype either dy by dx or dx by dy, isn't it? That is enough. That is the main thinking of the evaluator. Fine. I think these two types are briefly given to you. I will give the list of questions to you as daily test on dy by dx and dx by dy model. You can practice more number of questions on this model. Can I take the other one? Special case of linear? Fine. Shall I erase this? Okay. Now we go to the other one, that is Bernoulli differential equation or Bernoulli's differential equation, we can call upon. So the main difference between linear and Bernoulli equation is the form of linear equation is dy by dx plus py equal to q, and for Bernoulli it is now where is the difference here? So on the right hand side, the dependent variable will come in the power, like y power n. So here n is not equal to 0 and n is not equal to 1. If n is 0, it is nothing but linear. If n equals to 1, you are going to convert it into variable separable form and you can integrate that. So generally n will be a number which is greater than 1, like y square, y cube, etc., etc. Now what happens if the equation is straight away given in this model? It is very easily to identify that it is Bernoulli. If you are able to convert the given equation into this form, it takes a little time to identify that it is Bernoulli, because linear and Bernoulli slightly varies with y power. So as linear equation has two models or two variations, Bernoulli also has the same two variations. So it is just like dx by dy plus p into x, q into x power n. Now see. So usually people get confused with Bernoulli model. What type we have to use? dy by dx Bernoulli type or dx by dy Bernoulli type? So here also in the RHS, the dependent variable will come to the right hand side, like n square, x square, x cube, like that. That is the main difficulty here. And what is the procedure to solve? The thing is, we convert Bernoulli into linear. Then we solve the model. How to convert? Let me say, for example, if we have y power 2 is there, so multiply the total equation with y power minus 2. So right hand side, this part is eliminated, y square part is eliminated. So you are going to take the variable as take z is equal to y power 1 minus n. So here n is equal to 2. You are going to take that y power minus 1 is z, differentiate that, substitute the respective differentials in the equation. So what happens? The linear form will come under the variable dz by dx. We follow the usual procedure of linear type. We evaluate the solution. In the final answer, in place of z, we substitute the respective value. Okay? Is the approach clear? Yeah. Once the approach is clear to you, then I go with the problem. Shall I continue then by taking a problem? Fine. So consider the equation please note down that now I am going to write it as so it is Bernoulli equation. So please take a note of that. So here p is equal to 1 by x and q is equal to 1 by x square. Fine. So to convert that into linear model, we multiply the whole equation with y power minus 2, nothing but we divide the equation with y square. So what happens? Y power minus 2 into dy by dx plus 1 by x into y power minus 1 is equal to 1 by x square. It will come like this. Now, the thing we need to remember is, since you know what is p, whatever the value beside p, that means this part, it must be taken as z. I am using the symbol z, you can use any symbol, u, some other symbol p, q, etc., etc. For my convenience, I am using z. Fine. So whatever the value is there beside p, that will be taken as z. So put z is equal to y power minus 1. If you differentiate, dz by dx is equal to minus y power minus 2 into dy by dx. So if you substitute this value here, so implies that now can you identify it is converted in the linear form like this? Please check and ask your doubts. Please observe the pattern, then ask your doubts. How the Bernoulli equation is converted into linear type. So here, dependent variable is z, independent variable is x. So independent variable is not going to change, we are just changing the dependent variable. Fine. Any other queries for anybody here at this step? How to convert into the linear form? How it is taken? To anyone? Okay. So here onwards, we follow the previous procedure, finding integrating factor and evaluating the solution. Everything is common. So integrating factor is e power integral minus 1 by x dx. So e power minus log x, so nothing but 1 by x. And z into integrating factor equals to integral q into integrating factor dx plus c. This is the general solution. So z into 1 by x equals to integral minus 1 by x square into 1 by x dx plus c. I think you are able to solve this integration, and in place of z, you are substituting what z is. Z is nothing but 1 by y. So 1 by xy is equal to something is our required solution. Fine. Are you getting the idea here? So let me take one more thing on this type so that you will have an idea. Shall I continue on the same type? Bernoulli. So please take a note of this, then tell me. I will take the other type too. For each model, I will take the problem. I don't leave any model. I am going to take the first type again. I am going to take one more problem on the first type. On the dy by dx model only, I am going to take another problem in Bernoulli. Shall I continue then? Thank you. So you can feel that it may be somewhat difficult but easy. Please note down the problem, then inform. So on the first look, using the terms tan y, tan square, on seeing them, it looks little scary. Accepted? Or you feel that this problem is easily solvable on seeing the first look? Yes or no? So, whether to identify it is Bernoulli or not, the criteria here is, see, it contains only one derivative, dy by dx. Its power is also 1, so it is first order, first degree. So for the given equation, the only possibility is either exact, integrating factor, linear, or Bernoulli. In order to identify Bernoulli, the dependent variable must have more than power 1. Since y square is presented here, we can come to the conclusion that the dependent variable has power 2, so it is Bernoulli. That is the way to identify that whether given equation is linear or Bernoulli. Accepted? Say? Any doubts? So let us convert to the standard form. Now it came into the form dv by dx plus py equal to q into y power n. So here p is equal to minus 2 tan x, q is equal to tan square x. So divide with y square on both sides. So y power minus 2 into dy by dx minus 2 tan x into y power minus 1 is equal to tan square x. For the conversion, we do the same earlier procedure, taking that y power minus 1 equal to z. We go with the previous method. So I think that is not necessary to write again. Shall I substitute the values straight away? Say, any confusion? Taking z. Yes or no? Right. So here minus dz by dx plus 2 tan x, minus 2 tan x into z is equal to tan square x. So this implies that dz by dx plus 2 tan x into z is equal to minus tan square x. So this is converted into the linear model. Z is dependent, x is independent. So go with integrating factor. So integrating factor equal to e power integral 2 tan x dx. So what will be the value there? E power 2 log secant x. So it is nothing but secant square x. Coming to final solution, z into secant square x equals to integral minus tan square x into secant square x dx plus c. Now we have to evaluate the integral. Any hints from your side? How to solve? Yeah, that's a good one. Take tan x equal to t. So secant square x dx equal to dt. If you take like that, then it is nothing but integral minus t square dt plus c. So nothing but minus t cube by 3 plus c. So in place of t, we substitute it is tan x. In place of z, we substitute it is 1 by y. So that gives the final solution. So in Bernoulli type, can you say that it is a little bit complex compared to general problems? Say, or easy to understand and solve? Yeah, not much, a moderate one, acceptable. So this kind of thing you can expect for 10 marks weightage. Fine. The level of questions under UPSC on Bernoulli you can expect under this model, the moderate level. Fine. So I want to take one more thing of the type dx by dy. Shall I? Okay. Okay, please take a note of that. After noting, please inform. Thank you. Please take a note of this problem. So since you know, I am giving the hint that it is Bernoulli model of dx by dy type. So multiply both sides with the dx by dy. It comes under Bernoulli type. So you please convert into linear. From that part onwards, I proceed. Accepted? Is it comfortable for you to convert? Yeah. dy by dx into x square y cube plus xy equals to 1. So you multiply both sides with dx by dy, then it will come under Bernoulli form. So on conversion, I will say that you are going to get the form as please check on that. If the equation is agreeable to everyone, then I proceed further to each and every student. So you are going to take that x power minus 2, multiplying both sides with that, and it will be converted in the set form. So any difficulty for anybody in getting this equation? Please go ahead. Any doubts if you have? So shall I proceed then? Thank you. Now if you go with integrating factor, so e power integral y dy is equal to e power y square by 2. And coming to general solution, z into integrating factor equals to integral q into integrating factor dy plus c. So it is z into e power y square by 2 equals to integral minus y cube into e power y square by 2 dy plus c. Now I want recommendations from your side how to evaluate the integral. Yeah, very good. So take y square by 2 is equal to t. So y dy is equal to dt and y square is equal to 2t. So by making these substitutions here, it will come as minus. So y cube can be written as y square into y, so that y square is nothing but 2t, y dy is nothing but dt, and this is e power t. So in a simple manner you can write that 2t e power t dt plus c. So minus 2 into e power t into t minus 1 plus c. So that was the final answer. And in place of z, you can substitute 1 by x. It is nothing but 1 by x. So please take the answer one more time. Then you will confirm that. So is the solution clear to everyone? Now here I want to add one thing, that sometimes the given equation is not under linear model and also Bernoulli model. So we have a little small concept there that we call it as change of variables or substitution method. Now what happens whenever the equation contains second order, or sometimes on the right hand side a different function, by simply putting that value as z, that will be converted into linear form and you are going to solve with the usual procedure. So let us take one small example which gives you an idea. Shall I? Are you getting the logic what I am saying? Or no? Fine. So let me take the problem first. I will describe it, then I am going to say the method. So please note down the problem that please note down the problem. Now see, is it linear? If you want to say that it is linear, y should be presented here and right hand side only x should come. Is it Bernoulli? No. Because right hand side you have a separate function, not y square, y cube, etc. are there. Now I am saying that whenever the given equation will not come under this category, then what happens? For such kind of problems, we use the technique that whatever the function is there on the right hand side, by using that, we are going to convert it into the linear model. So if you multiply both sides with e power minus y, it will be e power minus y into dy by dx plus 1 by x into e power minus y is equal to 1 by x square. Now, if you want to convert that into linear, what I have to do? I should introduce some variable that e power minus y must be z. Accepted? So I put that e power minus y is equal to z. So minus e power minus y into dy by dx is equal to dz by dx. Substituting the respective values here, minus dz by dx plus 1 by x into z is equal to 1 by x square, which gives us dz by dx minus 1 by x into z is equal to minus 1 by x square. Now, do you accept that it is linear model? All of you? Say yes. So what is the technique I deployed here to convert into the linear model? Nothing but the different function which is there, I used that as z so that it gets in the form of linear. So that is my intention actually to say earlier. If the given function will not come, I mean the given equation will not come under the category of linear or Bernoulli, by suitable substitution. What is meant by substitution here? Whatever the extra function is there, we take it as z so that it will come under the category of linear. Fine. Now, are you able to solve that problem on your own? So please go ahead and give me the answer. So I will write this final solution, you can match that. This is my answer, please match with that. So here z is nothing but e power minus y. So in the final solution, we have to replace z with the original function, that is mandatory. And integration constant must be presented there, plus c. Thank you very much. So any queries in this approach to anyone? Right. Then let me take the other one. So please note down this problem. We call it as substitution method or change of variables method. We call like that. However, the method substitution is comfortable to remember. Yeah. Now, on the first look, we say that it is a second order differential equation. Agreed? Because d square y by dx square is presented in the equation. However, it comes under second and higher order differential equations category some equations are solvable by substituting the derivative as some z. So what I am saying, I take that dy by dx is equal to z. So this thing is nothing but dz by dx. So dz by dx plus 1 by x into z is equal to 12 log x by x square. It will come under the linear category. Please observe that. So this technique is applicable whenever it is a second order differential equation, and not for all, whenever usually constant is not there. So we can say that the equation is reducible to linear form by taking the differential as z. Fine. Now what happens, once the solution is obtained, then in place of z, you need to put dy by dx. Again, you have to integrate. That was the typical thing here. So, are you able to solve this integration, the linear model? Say yes or no? Everyone. So please go ahead with that solution. I will write the answer to you. Please compare and tell. I say that z into x is equal to please check on that solution. Yeah. If everyone is clear with that, then I move further. Everyone must reach at this step. Fine. So first of all, z is equal to take x to this side. Now we have z is nothing but dy by dx. Now you make it variable separable, and then integration constant will come. So you are going to integrate this expression. Now is the approach clear? Say. So are you getting the ideology behind this? So this is my intention, that whenever the given equation does not come under the formula or form of linear and Bernoulli, so we have two more things, nothing but substitution method. One thing is putting dy by dx is equal to z. Another one is taking the right side function as z. So that will be somewhat comfortable. It is not suitable for all, but comfortable in solving many of the questions. Let me take one small idea here to you. I will give an exercise for you. You can solve on your own. The importance of this method, what I am discussing. Suppose the equation is given like this. Please note down. I will give the method you will evaluate it on your own. So under the category of change of variables or substitution method, we have three types. First one is the right hand side function model. Second one is taking dy by dx equal to z. And the third one is this type. It comes very rare, not in general always. So whenever this kind of thing is there, we use polar coordinates to transform. So I say that you take x is equal to r cos theta, y is equal to r sin theta, x square plus y square equal to r square, and y by x is equal to tan theta. We do these usual substitutions there. So if you substitute these values here, on simplifying, it will simply come as variable separable. On substituting these values in the above, it will come as variable separable. All r values on one side, all theta values are one side. However, I give the idea that will become as the final thing, which is variable separable. Straight away you can integrate that. Fine. Substituting these values, simplifying the whole terms, you are going to get the thing like this. 1 by square root of a square minus r square into dr is equal to d theta. So in the end, in place of r square, we substitute this value. That's it. So is the ideology clear? So this kind of thing will come very rare. Whenever square root thing is there, this type of problem is given. In that case only we use this polar coordinates. At the most complexity we can expect is the previous two things. Putting dy by dx is equal to z and taking e power minus y is equal to z like that. This thing will come. As far as my knowledge is concerned, this model is not yet asked. If at all, just once it is asked. I hope so. Fine. So this is all about linear and Bernoulli differential equations. So I will give you a list of problems to you on this model, and I am going to start with orthogonal trajectories, the next topic. Any questions so far on the previous topics? If you're interested, it is okay. Otherwise, I will take freshly on Monday orthogonal trajectories. More models on that. Fine. Thank you very much. Any queries so far? Let us have a discussion thing now. Then we can wind up our session today. Sure. So can you substitute the values there? Please go ahead. All of you. So I will substitute the respective things. So dx, since x is equal to r cos theta, for dx we write it as since y is equal to r sin theta, dy is equal to so that you are going to substitute the things. Okay, please substitute that. I will say that on substitution, you are going to get the things as r cos square theta plus r sin square theta into dr by r square cos square theta plus r square sin square theta of d theta is equal to square root of a square minus r square cos square theta minus r square sin square theta by then simplifying the terms you are going to get like this. And the final solution will be that is the final answer. Please check on that. So if you simplify, this is the thing. You go for variable separable. You integrate the value. This is the solution. That it will come like this. In place of r, substitute r value. In place of theta, substitute theta value. Because we have y by x is equal to tan theta earlier. So theta is equal to tan inverse y by x. So square root of x square plus y square equal to a into sin of tan inverse y by x plus c is the final answer. Okay. So please solve on your own and confirm the answer. So whenever this kind of thing is there, obviously you can expect 15 marks weightage as far as the substitution is concerned. But for linear and Bernoulli, the maximum weightage is only 10 marks. Because it takes little time to identify that we are going to use polar coordinates here. And evaluating that, it will come under the category of variable separable. Accepted? That's it. Any other queries, please? And let me ask one question. As the daily test is given to you and it is concerned, I have given the problems as per the order straight away. So on observing one or two problems, you can easily identify 1 by n or 1 by m is the integrating factor for that we are going to apply. Is there any difficulty for you in identifying the integrating factor for those questions? And one other thing you can say, those problems, if you little bit practice, can be solved by means of inspection method also. Apart from doing integrating factor everything, you can check that by simply rearranging the terms, am I able to get the solution? For that, I will give one small hint that since you have solved them already, by checking the answer, try to get or try to represent the given equation as a derivative of some function. If at all it is possible. Otherwise, you leave it. I am just giving that inspection method can also be applied like this for those problems. If you are interested. Otherwise, you stick on to the standard methods. There is no need to go more. Okay? Are you getting the thing? It is possible only for some kind of problems, not for all. So thank you very much. If you have any queries, you can ask. Otherwise, let us wind up our session here. And tomorrow we will meet with orthogonal trajectories. I stick on to the procedure approach and take the list of problems to solve in the class. Okay. Thanks and good night to all.